Hello, I'm Bryan Atkinson and welcome once again to UK Aircraft Explored. In this video we shall cover standard beam approach within the Avro Lancaster bomber. We shall look at how it worked and the equipment used. As always, we shall be referring to wartime air ministry manuals. I hope you find this interesting. The German Lorenz-based beam approach system gave tired bomber crews much needed assistance when making a blind landing at night or in bad weather. The Royal Air Force called their version of the system Standard Beam Approach, or S.B.A, along with its modification Tunable Beam Approach, which was T.B.A. Both are designed to provide pilot-interpreted audio signals giving accurate indication of the runway as a azimuthal approach path and, in the concluding stages of the approach, warnings of the proximity of the touchdown point. The systems therefore enable an aircraft to land safely under conditions of poor visibility, when the runway may not be seen until the aircraft is approaching the airfield boundary. Each system employs 3 ground beacon transmitters known as the main beacon and inner and outer marker beacons. The main beacon provides an equisignal type beam which lies along the direction of the runway, while the 2 marker beacons transmit vertical fan-shaped lobes of radiation at fixed points along the approach path. The aircraft equipment consists of 2 receivers, one of which is tuned to the main beacon frequency and the other to the common frequency employed by all S.B.A marker beacons. The ground beacon installation was subject to certain sighting difficulties, and for this reason the system couldn't readily be made mobile. Erection and initial operation was likely to take anything from 1 to 3 months. Here's a look at how standard beam approach worked. The main beacon is installed about 300 yards away from the upwind end of the runway. By the use of a suitably spaced aerial and reflector, a roughly cardioid polar pattern is radiated. The introduction of another reflector on the opposite side of the main transmitting aerial and the alternating switching of the 2 reflectors produces 2 cardioid patterns overlapping along the centre line of the runway. If the reflectors are alternately switched in accordance with some interlocking pattern of Morse characters, i.e. dots and dashes, the bisector of the overlap of the cardioid patterns will then form an equisignal. Thus, a continuous note will be heard when the aircraft is along the line of the runway. An aircraft either side of this equisignal will receive dots and dashes in accordance with the switching of the cardioid in which it is situated. For some small distance immediately to either side of the equisignal, a twilight zone is experienced in which the predominating Morse character of the superior cardioid is heard against the continuous background note of the equisignal. In order that the pilot may have indication of when to commence his letdown, marker beacons are placed along the approach path to the runway. These markers also serve to identify the correct approach path, for in addition to the runway beam, there is also a reciprocal or back beam. The marker beacons are known as the inner and outer markers and are situated at approximately 50 yards and 3,000 yards respectively from the point of touchdown. They both radiate horizontally polarised fan-shaped polar patterns and operate on the same frequency. Owing to their distance apart, the radiation zones of the 2 markers do not interfere with one another. The inner marker beacon is modulated to give a series of high-pitched dots, and the outer marker a series of low-pitched dashes. The marker beacon signals are received on a separate aircraft receiver, which remains permanently tuned to the common marker frequency. An additional indication of position is available in the form of a cone of silence, situated directly above the main beacon. In this area, the main beacon signals fade out completely. The main beacon operates on a frequency in the 30.5 to 40.5 megacycles per second band. This helps to ensure that the width of the main beam is such that it is impossible for the aircraft to land off the runway when flying in the steady equisignal zone. It should be noted, however, that the beam is susceptible to bending when there is any reflecting objects close to the main beacon. The ranges of the front and back beams of the main beacon are approximately 40 miles, dependent on height. The marker beacons may be received up to the height of about 6,000 feet, and the cone of silence can be discerned up to the height of approximately 2,000 feet. On low power operation, the beam range may be reduced to about 25 miles, again dependent on height. Since the aircraft does not transmit, its position is not divulged. And now for a look at the S.B.A. equipment in the Lancaster. The aircraft equipment consists of a power unit, a control panel, 2 receivers and their associated aerials. The complete installation weighs approximately 60 pounds. The beam approach equipment in the Lancaster is installed in the rear centre portion of the fuselage at the flare station and is mounted on a platform between the flare chute and the bulkhead at former 22. The main beacon receiver R1124 is fed from a whip aerial and is remotely controlled by Bowden cables from one of 2 types of control units and is mounted on the port side. The marker beacon receiver R1125 is mounted under the starboard side. It is spot tuned to the beacon frequency of 38 megacycles per second and is fed from a dipole aerial mounted under the rear port ventral surface of the aircraft. The 24-volt power unit Type 12 is fitted between them. The main junction box Type 7 is mounted above the signal receiver. The pilot's beam approach visual indicator is mounted on the left side of the main instrument panel. When the control unit Type 6 is employed, the aircraft's installation is known as Standard Beam Approach or S.B.A. It is mounted along with the mixer box on the pilot's auxiliary panel on the port side of the cockpit. It provides remote tuning control of the receiver to one of 6 spot frequencies in the 30.5 to 40.5 megacycle per second band by means of a frequency selector handle coupled to the receiver by Bowden cables. Fine-tuning of the spot frequency is provided on a separate fine-tuner control. The main on-off switch completes the input circuit to the power unit and controls power to both the main and marker beacon receivers. The volume control affects only the main beacon receiver signals, those from the marker beacon receiver always being heard at full volume. The test normal switch should always be switched to normal. When control unit Type 252A is employed, the aircraft installation is known as Tunable Beam Approach or T.B.A. This unit provides remote slow motion tuning of the receiver through the 30.5 to 40.5 megacycles per second band and also incorporates an S.B.A, mix and IC switch. In position S.B.A, the signals are only heard in the pilot's headphones. In the mix position, pilot and crew both hear the S.B.A signals and have intercom facilities, while on the AC position, pilot and crew are disconnected from the S.B.A and have only intercom facilities. The other controls on this unit are similar to those of the control unit Type 6 and have similar functions. The fine-tuning control on the Type 6 unit is of course unnecessary with this type of control box. We shall now go through the pilot's procedure in making an approach using standard beam approach. A pilot intending to use an S.B.A. installation for making a landing approach should manoeuvre his aircraft to arrive at a position on or near the equisignal approach sector and about 5 nautical miles distant from the aerodrome. He should then keep the aircraft within the equisignal approach sector while approaching the airfield and maintain the correct line of descent. The pilot should obtain the following oral indications of his position relative to the equisignal approach sector. If the aircraft is within the equisignal approach sector, a continuous note will be heard. If the aircraft deviates for more than about half a degree from this sector, it will enter a twilight zone. The pilot will then hear, superimposed upon the continuous note, faint Morse dots if the deviation is to the left, or faint Morse dashes if the deviation is to the right. If the aircraft deviates still further, either dots or dashes only will be heard, depending on whether the deviation is to the left or the right. Before using the installation, the height at which the aircraft would fly over the respective marker beacons in order to maintain a correct line of descent for landing should be determined. When passing over the outer marker beacon, a low-pitched signal will be heard for a few seconds, emitted at the rate of 2 dashes per second and superimposed on the signals of the main beacon. The outer or O lamp will flash on the pilot's beam approach visual indicator. When passing over the inner marker beacon, corresponding signals of a high pitch will be heard emitted at the rate of 6 dots per second. The inner or eye lamp will flash on the pilot's beam approach visual indicator. Rate of descent can then be adjusted accordingly. Later S.B.A. systems adopted Morse A's and N's instead of Morse dots and dashes, but the principle for both is the same. Well, that's it for this video, and happy landings. If you like what I do on this channel, please click the like button and please subscribe, and also click the bell. Remember, it's free and you'll receive notifications when my future videos are posted. Thanks as always for watching, and I'll see you again next time. Bye for now.